All right, this is EOC review. I'm finishing up that very back page, so this is part 2. I already did part 1 where I did all the other questions. Now I'm recording part 2. Okay, so in the first question, it's saying there are 60 students going on a field trip to a chocolate factory. The students are from different classes. You got Mrs. Hooper's class, where there are 24 students, Gomez class, where there are 18 students. Which of the inequalities or which of the equalities, because they're all equal signs, correctly describes the students and could be used to solve how many students are in Mr. Anderson's class? Anderson's class is the only class that's missing. And the total is going to be how many? What's the total of everybody? The total of everybody is 60. So everything equals to 60. So what are we adding together to get 60 there? We're adding Hooper's class. How many students in Hooper's class?
24.
So we got 24 plus Gomez, 18 plus, who's the other teacher? Did they tell us how many in Anderson? No. But all should equal what number? 60. So what's going to be the answer here? D. D is going to be the answer. Okay. It says the ages of 3 friends are consecutively 1 year apart. Okay. So when you see that, when you see consecutive, when they're back to back, this is how you work out a problem that's similar to that. Okay. So you're always going to say that the first friend, it's 3 friends. So you got first, second, and third friend. There are 3 friends. The first friend, we don't know their age, is going to be X. The second friend is 1 year after that, so that's X plus 1. And the third friend is going to be 2 years after X, which is X plus 2, because they're a year apart. So if X is 5, then if this person is 5 year old, then this person will be 6, and this person will be 7. You get it? So it's X, X plus 1, then X plus 2. Any questions about that? First person, second person, third. Y'all get it? Yes, no, maybe so. Thumbs up at least, shake your head something. Okay, all right, thank you. Okay, so now all together is 48. So we got to add them all together. So how we add them together? We have x plus 1 plus x plus 2 equals how much? Equals 48. Okay? Which equation can be used to find the age of each friend where I should have used A instead of X. So let me change the X's to A. A, A, A. Okay? All right. So which can I use? Which is the answer here? D. Do y'all see how D is the answer? Okay. Does that make sense? Hello?
Yes.
Thank you. All right, so now we got to find each of the friends' ages. So we're going to solve this equation. So we're going to do parentheses first. We can't add terms that are not alike. So we don't need the parentheses anymore. Okay, take it out of the parentheses because you can't do anything with them in the parentheses. So now we're going to combine all the like terms. What terms are alike here? The A's. 1A, 1A, 1A. Okay, so we got 1A plus 1A plus 1A. What's that? That's 3A. So we've added all the A's together. What else can we add together? 1 plus what? 2. What's 1 plus 2? So this is plus 3. Bring down the equal and the 48. Any questions about combining like terms there? Are y'all okay with that? So now let's solve for A. How do you get A by itself? What are you going to do first? You're going to subtract 3 on both sides. So this gives you 3A is equal to, what does this give me?
45.
This is 45. So now what do I do to solve for A on each side? Divide both sides by 3. So this gives me A is equal to what number?
15.
It's A is equal to 15. So the smallest person or the youngest person is 15. So what's the next person's age? 16. What's the next person's age? What answer choice is that? That's what now?
B.
B. Yeah, that's B. Okay, number 3. Are y'all okay? Am I moving too fast? Did you show your work, baby? Okay, all right. Okay, so number 3, it says the student council is renting a tent for $350 for an upcoming student fair. Each student attending the fair will pay 50 cents. So every student that's attending, I might come right here, is going to pay 50 cents. Okay, so 50 cents for each student. Okay, that's what each student is going to pay. Okay, other people are going to pay $2.25. The others pay this. This is what others pay. Okay. It says if 200 students attend, okay, so 200 students are attending. So we can multiply that together, right? So we got 200 students times the 50 cent. Oops, and put that in parentheses. 50 cent, okay? And then you got the other people pay this amount. But yeah, yeah. Thank you, babe. So we got again, um, sorry, student council is renting the tent for this amount. That's the total amount they're renting it for. Oh, look how 350. So we know it's got a total up to 350, and we know the amount has to be greater than or equal to because all of these are greater than. Okay, so we got 350. This is a given that the total amount has to be equal to or less than the 350. Greater than the 350. All right, so each student attending the fair will pay 50 cents. It's 200 students, so that's 200 students times the 50 cents. They're wanting you to write an inequality that can be used to determine the number of the other. We don't know how many others. We don't know how many others there are, so we're going to use a variable. It looks like they're using the variable A. So we're going to add this, multiply this together, plus the amount that the others pay times A. And this amount should be greater than the $3, than the $350 for the tent. Okay, they have to make more money to pay for the tent. It can't be less money. This can't be smaller than, because then they ain't gonna have enough money to pay for the tent. Okay. Any questions about that? What answer choice is that, by the way? Yep, B. Any questions about how we got B or how I came to that conclusion? Number 4. Anybody still writing? Are you okay with it? Are you okay, Jamie? You all okay in the middle? Are you? Okay. All right. Number 4. It says a heart-shaped chocolate box is composed of one square. So we got one square and two circles. Okay. The total number of chocolates in the box is calculated by adding the area. So they're adding the areas together. This area right here and the area of the circle, this area right here. So they're adding those together. The company plans to add, so now they're going to add an additional box promotional campaign containing this right here, 2x. So we're adding these together. It says if the total combined heart shape and the small box contains 69 chocolates, so it's equal to 69. Look, all of these say 69 equals 69. Which of these equations could be utilized to solve the number of chocolates in the small box? Okay, so we're adding. Wait. Whoa. Which of the equations could be utilized to solve for the number of chocolates in the small box? Just the number of chocolates in the small box? All right, so how will we do that? Just the number of chocolates in the small box. So what do we do to just determine the number of chocolates that are in the small box? We got to subtract. What are we subtracting?
4x is second power minus 3x is second power.
Yes, we do have to subtract those. And then, let me see. But I don't see. Oh, here it is right here. They're subtracting these. feel like it should be subtracted from, it's just what is left in this box. This is the only box that they want. So it's got to be B as your answer. You know, at first when I looked at this, I thought that it was A. But this last part I didn't read. They just want to know the chocolate that's in this box. So you have to subtract these areas, and then the only it's left, it's what's in the box. It's what's in this right here. First I was adding them all together, but you're subtracting. That sucks. All right, number 5. It says an internet business sells U.S. flags for $16.95 each. So every single flag is $16.95. Plus, you have to pay $2 shipping for every flag as well. Shipping, um, oh, I see. Shipping per flag. Shipping is free, however, on the orders more than, wait a minute, $2 for shipping per flag. Shipping is free. What? However, on the orders where more than $100 were purchased. Oh, okay, more than $100 were purchased. Okay. I was going to say. All right, which one of these, which is correctly shows the number of F flags that can be purchased to get free shipping? All right, see if you get that one. I'm gonna pause to see if you can get this one. Any guesses? Huh?
D.
D, some people say. Nope, that's not right.
I got A.
No.
Oh, is it C? I really picked C.
The answer is C. Okay, it's C because it's for every flag. You got to pay $16.95 for every flag. Plus, you have to pay $2.50 for every single flag. So, this is going to be 5. 9 is going to be, this is 14. This is going to be 6, 7, 8, 9. And this is going to be 1. So, it's $19.45 for every single flag, as long as this amount is uh, greater than 100. After it goes over that amount, then shipping is gonna be free. All right, so number 6. See if you can get number 6. A farmer has a rectangle. Please draw the rectangle. Okay, has a rectangle that measures 100 by. Oops, let's put the 100 on the smaller end. By 150 feet. He plans to increase the area of the field by 20%. You got to figure out what that is. He will do this by increasing the length. So he's going to increase the length and he's going to increase the width by X. Okay, look at your equations. Which equation represents the area of the new field? See if you can come up with an answer there. Okay, I have a question for you. The first part, do you see how it's saying that this is the original dimensions of the rectangle? Okay, to find the area of this rectangle, I would multiply 100, right, times 150. So we got 100 times the 150, and what does that give me? That's the small one, right? Okay. Now, that's not, is that right? 1, 2, 3 zeros. 1, 2, 3 zeros.
Myers, come to the front office or call 111. Samaj, come to the front office or call 111.
So, so that's the area of the original. Does that make sense? How we found the area of the original? Okay. He plans to increase the area by 20%. Okay. So to find this increased amount, what is it going to be? You got to find 20% of that. So to find 20% of 15, how many zeros did I say? 3. You're going to multiply by 0.20. That's 20% to figure out how much it increased by. Okay. Are you following me so far or no? Okay. So let's do that. 15, 1, 2, 3 zeros times 0.20. What is that amount? Come on, type it in. What is this amount?
18,000.
Okay. So the area is going to increase by 18,000. Does that make sense to you? Okay, so the new area has to add up to 18,000. Well, no. Wait, sorry. It has to add up to 18,000. You're right. Because we added, really, this amount is not equal to that. It's equal to 3,000, right? But then this is the increase. It's going to increase by this. So how do I figure out what the total is? I add it to it, which would equal that 18,000. Do you understand? So this is the new area. Okay. So that's what the new area is. So I can go ahead and eliminate B and D, okay, because we want to know the equation for the new field. Does that make sense? How I can eliminate those? So now how is it being increased? Remember, this is area is length times width, right? How did it say that you was finding the length and the width? He will do what? He will do this by increasing the length and the width by what? The same amount, what? X. Okay, so one of the length is either 100 or what was the length? 100. So he's gonna what? Say again. No.
It is the same.
So how is he planning to increase it? Which one of these is the correct answer? No, I don't understand how you get A. You have to explain to me the logic of. It says 2x.
Oh.
It's increasing by x. So they have to add x to the 100, right? And add x to the what? Somebody said it, 150. And it should equal to the new area of 18,000. Ms. Reyes, I don't know why I keep putting a comma in the same crazy location. What letter option is that?
C.
That is C. Do you see that now? It's saying it's increasing by x. So I'm adding x to the length, which was 100, and the width, which was 150, and it equals the new area, which is 18,000. Jamie, are you okay? Are you sure? What about you? You sure? Okay. And that's the end of this one. Okay.